This is chapter 7, the higher course. Now there's only two parts, 7.1 and 7.2. What they've done here is to take grade C concepts and stretch them all the way up to grade A in some places. In fact, some of the grade B questions here in the higher course I've actually done under the foundation course. You've got to see the foundation video, so you've really got to. I'm just going to do the odd question here and there, but not too many. I'll do most of them in the assess. So this is section 7.1 and it's called properties of quadrilaterals. Well, I'm not going to do any of that. I'm just going to jump straight to question 8, and that's what this is right there in front of you. So I'm going to use my knowledge of quadrilaterals and your knowledge of quadrilaterals, which you've just gained from watching the foundation videos, I hope, to apply that knowledge to question 8, which I didn't do in the foundation course. Question 10, I recognise it as a question I've done in the foundation course, so it's a really good question for you to look at and obviously look at the video. So it says there in the diagram, I've got EF is parallel to GH, so EF is that line across there, GH is across there. Basically they're setting the scene, so I've got two parallel lines. I'm also told that AB and CD are also parallel, and they cut across these other two parallel lines. I'm told that IJ is perpendicular to AB, so IJ is that one and cuts AB at right angles, so guess what? That's also 90 degrees, and so is that, and so is that. All these are 90s. And IK is equal in length to JK. So this length here and this length here are equal. Now I want to demonstrate it by doing something like this. Now there's an awful lot going on here, but we've not even started, but let's just go for it. It says calculate angles A to F and give the reasons for your answers. Please note giving reasons. Let's just take a look here. Loads of ways of doing this. If I've got 65 there, this angle is also 65 degrees because it's an alternate angle. 65 is also there because they're alternates. That's my reason. And also A will be 65 because it's corresponding to the angle shown there. So I've got my blue angle 65 degrees, completely corresponding to the angle A there. So A is 65 degrees. I could even say opposite angles in a this is going to be a parallelogram, isn't it? So this and this makes a parallelogram. I could say opposite angles are equal in a parallelogram. Then if I can say 65 degrees straight away. I went down the alternate angle route and then I made that 65 corresponding to that angle A, which is also corresponding. Let me just tidy it up a little bit. I'll get the phone because there's nobody else in the house. So that's A done. Now B, loads of ways of doing this, I suppose. If I can see 65 there, I can see that this is also going to be 65 outside here because it is an alternate angle, so that is alternate to the 65 there. And B is going to be, well, it's on a straight line, so 180 take away 65, that's going to give us 115 degrees. Alright, so I'm not going to necessarily write down every time, you know, angles on a straight line add up to 180 degrees. You can just see from the calculation what I've done there. Alright, so A and B are done. Now what about C? Well, C is going to be vertically opposite to the 65 shown. I can in fact say really that 180 take away B, which is the 115, will leave me 65 anyway. I can see straight away that the 65 shown there is vertically opposite to angle C, so I'm going to write the word vertically opposite, so I've not used that yet. And so after C comes D. Let's just take a look what we've got here. Angle A is 65, that's 90 inside there. So D is going to be, let's work down here, I ain't got a lot of space, so D is going to be 180 degrees, it's sitting inside a triangle. Take away 65 and take away the 90, and that's going to give us an answer, isn't it? Grab my machine because we're allowed to do that. Essentially 90 take away the 65, that leaves me with 25 degrees. Alright, so I've got D. Now after D comes E. Now look, here's a nice piece of information. I'm told that IK and JK are equal in length, which makes the triangle IKJ isosceles. If that's the case, then angle D being 25 there is also 25 in this corner here. So I've got a 25 there and a 25 there. So I've got an isosceles triangle. So let's just go back to this then. E is going to be 180 degrees, it's a triangle. Take away my two 25s. And that's going to be 130 degrees because it's 180, take away 50, and that's what I've got there. So I'll put a little bracket here, isosceles triangle. I'm trying really hard to get it to work. Alright, so that's my justification for that. I'm giving my reasons. So E we've got, and after E comes F. Well, I've got a 90 there. I'll shade it in. I know C65, I can work out angle F straight away. Again, I'm sure there's other ways of working it out, but I'm going to go for F as follows. So F is going to be 180 degrees because it's in the triangle. Take away this 90 here, and take away the 65 just there, which is the C angle, and that's going to give us, once again, 25 degrees. Alright, so that's the end really of section 7.1. That's all I need to do. All the others have been done before. Like I said, it's essentially a grade C topic that's been made all complicated and difficult and bumped up to grade B. In fact, the book doesn't say it's grade B, but it is essentially at that level because there's an awful lot going on. Plus, if you have to justify every calculation you do, we're using words like vertically opposite, alternate, corresponding, isosceles, not grade B words, but taken as a whole, it's more challenging than the average grade C question you'd get when playing with parallel lines and angles and all the rest of it.